Good afternoon, friends. Today we are going to continue our physics lesson from our last video, which was last week. And we still talk about the same topic, which is heat capacity. So in the last video, we discussed two questions, okay? Question number one, number two. Today, we are going to look at two more questions, okay? So we start with question number three. Okay, here we have question number three on board. Okay, I read the question and then we discuss together, okay? Calculate the initial temperature of an iron beam if 230.4 kg of heat energy is supplied to heat it to 100 degrees Celsius, given that the heat capacity is 2880 joule, C power minus 1, okay? All right. As usual, we need to write down what we know from this question in order to enable us to find out what we do not know, okay? All right, so let's see what we have in here. We write down what we know from this. This is heat energy, okay? So we have calorie here. This is Q equals 230.4 kJ. And heat capacity, okay? So the calorie is the calorie or the energy, okay? Energy required, energy needed, 230.4 kJ, and heat capacity, it's there, 2880 joule. Yeah, that's Celsius power minus 1. To make sure it's correct. Degrees Celsius, okay? So degrees Celsius power minus 1. I forgot to put degree here. Okay, degrees Celsius power minus 1. And what else we have? Heat it to 100 degrees Celsius. So this is T2, or final temperature, okay? Final temperature is 100 degrees Celsius. Now, calculate the initial temperature. So that is T1, okay? T1. T1 is unknown. We need to find it. Okay, we have written everything that we know from this question. Now, we need to select a formula in order to help us work out this question. I want to make this very, very easy, okay? Super easy, okay? Super easy, so that you friends can easily work out questions like this, okay? So we have T2 minus T1, okay? T2 minus T1 equals delta Q over C, okay? T2 minus T1 equals delta Q over C. We use this formula to help us solve this question, okay? Find the answer for these questions. So we know that our T2 here, okay? T2 is 100 degrees Celsius. So we can put this in the bracket, no problem. So 100 degrees Celsius minus T1, we don't know T1, so we just put it there, equals, now delta Q, we have Q here, 130.4 kJ over heat capacity, okay? Over heat capacity. Our heat capacity is 2880. 2880 joule degrees Celsius power minus 1, okay? Degrees Celsius power minus 1. Okay, we continue here, okay? Now, before we divide these numbers we have here, we look at the units we have. Here we need to convert this first, okay? We need to convert to 230.4 kJ to J. So we multiply it with 1000, okay? We want to convert it to joule instead of using kilojoule. So this is kilojoule, we want to convert it to joule. So 230.4 times 1000, okay, times 1000. So this is J here, over 2880 J degrees Celsius power minus 1. Okay. We bring here. We put here. Okay. We multiply this. We use our calculator to make it faster. So 230.4. 230.4 times 1000. We get 230,400, okay? Yeah, that's the number. 230,400 joule over 2880 joule degrees Celsius power minus 1. Okay, so we put here 100 degrees Celsius power T1, minus T1 equals this. Okay, now we divide the number, okay? We divide the number. 230,400 divided by 2000. Oh, I missed a number here. 0. 2880 joule, okay? Divided by 2880. 2880. We got 80, okay? We got 80 here. Now, we look at the units. We have joule here. We have joule here. So this joule and joule, we cross out. Cross, cross. Okay, now what we have here, degrees Celsius power minus 1, okay? Degrees Celsius power minus 1. So we bring here, this degrees Celsius, this is denominator. When we bring up there, okay, it becomes positive because this degrees Celsius power minus 1, we bring here, it becomes degrees Celsius power 1. So degrees Celsius, okay? We normally don't write power 1. Now we look here. So we have 80 there. So now we bring T1 out to be the subject. So we put here T. We want to find T1, okay? So we put T1 here. So we put T1 equals this T2, we bring over there. So 100 degrees Celsius minus that one, 80 degrees Celsius. Okay, so between 100 and 80 there is 20. So 100 minus 80 is 20. So it is 20 degrees Celsius. So T1, the initial temperature is 20 degrees Celsius, okay? The initial temperature is 20 degrees Celsius. So we see our final temperature, okay, to hit this iron beam to 100 degrees Celsius. This is final temperature and T1, so now we can put it here. T1 is 20 degrees Celsius, the initial temperature. Okay, initial temperature. All right, so we have got it. Now let's go through this quickly, and then I erase and we bring one more question. Okay, so we still talk about heat capacity. Okay, calculate the initial temperature, okay, of an iron beam if 230.4 kJ of heat energy is supplied to heat it to 100 degrees Celsius. Given that the heat capacity is 2880 joule degrees Celsius power minus 1. Okay, we wrote down what we know from the question, okay, in order to enable us to discover what we want to find out. So we have Q here, which is the calorie energy consumption, 230.4 kJ. Okay, the heat capacity, we use letter C here, 2880 joule degrees Celsius power minus 1, and T2, our final temperature is here, is 100 degrees Celsius. Now we use this formula, so T2 minus T1 equals delta Q over C, okay, calorie over capacity. Okay, these are the numbers, so 230.4 kJ, we convert this kJ to J, okay, kilojoule to joule. So we multiply with 1000, okay, multiply with 1000, we get 230,400 joule, okay, divided by, we divide that with 2880 joule degrees Celsius power minus 1. Okay, we have joule here, we cross the joule out, we leave behind degrees Celsius power minus 1. So we bring this degrees Celsius power minus 1 up here, minus 1, we bring here, it becomes degrees Celsius power 1, okay, degrees Celsius. Now, we come here, so that is 80 degrees Celsius. Now, we bring this, they want us to find the initial temperature, so we bring T1 out here to be the subject. So T1 equals 100 degrees Celsius, okay, this is the final temperature, okay, minus 80 degrees Celsius, it's here. So we get T1 is 20 degrees Celsius. Okay, friends, I'm going to erase this, and then we bring one more question, okay? You can always go back to watch it, okay? These very simple questions. Okay, let us look at our question number 4. Okay, our fourth question. So I put number 4 here. Number 4. Calculate the final temperature of a 3 kg block of copper. Of 3 kg block of copper. Okay. If 42,120 joule, 42,120 joule of heat energy was supplied. Of heat energy was supplied to heat it from a room temperature of 25 degrees Celsius, 25 degrees Celsius, dot comma there, the specific heat capacity of copper is 390 of copper is 390 joule kg power minus 1 degrees Celsius power minus 1. Okay. Yeah. 390 J. Okay. That's the question. Okay. So I read this question. Okay, I read this question and then we discuss together. Okay. Calculate before in the question number 3. They want us to find the initial temperature. Now here the final temperature. Okay. Calculate the final temperature of 3 kilogram block of copper if 42,120 joule of heat energy was supplied or was used to heat it from a room temperature 25 degrees Celsius. The specific heat capacity of copper is 390 joule kg power minus 1 degrees Celsius power minus 1. See, copper is low. Okay, the heat capacity of copper is very low. It's only 390 joule kg power minus 1 degrees Celsius power minus 1. So energy needed also not as big. If we compare this to water, in our last video, the heat capacity of water is 4,000 something, okay? About 4,000. So the calorie needed is 2 million something, okay? All right, let's look at this question. We look at this question to see what we know from this question, okay? So first of all, we take mass, okay? M, it's over there, 3 kg, okay? Let me see if this is correct, 3 kg. I want to make sure the number is correct. Okay, okay, 3 kg, and then okay, this 42,120 is Q calorie, 42,120 joule. And what else we know? Okay, T1 is 25 degrees Celsius, and the heat capacity is here, 390, it's low, 90 joule kg power minus 1 degrees Celsius power minus 1. Now, what we do not know is final temperature. So T2, okay, T2. So we need to find this T2. I want to check the question again to make sure that everything is correct, okay? Mass 3 kg, okay. The calorie 42,120 joule, correct. Initial temperature 25, initial temperature 25, specific heat capacity 390, okay. Okay. All right. Now we want to find the final temperature, or T2, it's here, okay? We have written down all what we know, okay? We have written down all what we know. We use this to find this T2. So we put here T2 minus T1, okay? T2 minus T1 equals, okay, we want to make sure that it's correct. Q over M times C. Okay, T2 minus T1 equals Q over M times C. Okay, we can continue from here. Okay, what is Q? The Q is 42,120. So we put here 42,120 joule over mass is 3 kg. It's here. So 3 kg times C, heat capacity, 390. So 390 joule kg power minus 1 degrees Celsius power minus 1. We need to write the unit. Okay? In physics, those units are important. Okay, we continue here. Friends, before we multiply, we divide the numbers we have in this question here. We look at the units first, okay? We look at the units. We get our red ink to cross this. We have kg here, power 1, and kg here, power minus 1. When you multiply things with power like this, you subtract the powers, okay? I mean, you add the powers. You add the powers. So this positive 1, negative 1. So we cross this kg out. Kg power 1 and kg power minus 1 are out. Okay, what else? We have joule here and we have joule here. So we cross the joule as well. Okay, so kg are out, joule are out as well. Now what we have left here is degrees Celsius power minus 1. Okay. We look at our initial temperature. So we put here T2 minus 25 degrees Celsius equals. Now we can multiply this number. So we use our calculator to make it faster. So 3 times 390. 3 times 390. We get 1,170. So 1,170. Oh, sorry, that's denominator. What am I doing? We bring this down. 42,120 over 1,170. 1,170. 1,170. Okay. This one here, degrees Celsius power minus 1. Okay, let's divide the number. Okay. So 42,120 over 1,170. We get 36. Okay. So here we get 36. Okay. 42,120 divided by 1,170 degrees Celsius power minus 1. We get 36. So this degrees Celsius power minus 1 here we bring up there becomes degrees Celsius positive. Okay, power 1. All right. Now we look here. What we have in here? T2. We take T2 out to be the subject. Okay. We take T2 out to be the subject. So T2 here equals, okay, and then we bring this in. So 36 degrees Celsius minus, plus here, plus, this is minus, becomes plus, move to the right side of the equal sign, becomes plus 25 degrees Celsius. Okay, so T2 equals 36, this one here, degrees Celsius, plus this one minus, so we bring over there, becomes plus 25 degrees Celsius. So it becomes 36 plus 25, 61, is it? Yeah. So T2, so this is 61 degrees Celsius. So T2 equals 61 degrees Celsius. Okay, so the final temperature is 61 degrees Celsius. All right, friends, we have done it. Let's go through this one more time and then I let you go, okay? Okay, calculate the final temperature of 3 kilogram block of copper. If 42,120 joule of heat energy was supplied to heat it from a room temperature 25 degrees Celsius. Okay, the specific heat capacity of copper is 390 joule kg power minus 1 degrees Celsius power minus 1. Now we need to write down all what we know in order to enable us to find out what we do not know or what they want us to find. Now I want to make this question very, very simple, very easy, super easy for you to know, okay, to know how to work out. So I want to make it very, very easy, very simple, okay. So we have written down here, M is 3 kg, it's there, 3 kg, that's M, mass, and then a calorie, energy required, energy needed, energy consumption, 42,120 joule, it's here, 42,120 joule, okay, this energy, okay, needed, okay, and then our initial temperature is over there, 25 degrees Celsius, okay. Start, so the heating process starts from here, so that's why we call it T1, okay, initial temperature, 25 degrees Celsius. Our the heat capacity of copper 390, it's very low, okay, only 390 joule kg power minus 1 degrees Celsius power minus 1. Now they want us to find final temperature, so that is T2. All right, so we use this here. T2 minus T1 equals Q over MC, okay, equals over MC. So Q 42,120 joule, and then M is 3 kg here, and heat capacity is 390. So T2 minus 25, because T1 is 25, is over here, equals 42,120 divided by 1,170. This 3 times 390 is 1,170. Now, we need to take care of the units as well. We have joule there, we have joule here. So joule and joule are out, because when we divide things like this, we subtract the power. So they cancel one another. Joule and joule cancel one another, and then kg here, this kg power 1, that is kg power minus 1. So power 1, power minus 1, they also cancel one another. Okay. So J and J are out, kg and kg are also out. Now we have left only minus degrees Celsius power degrees Celsius power minus 1. Okay, so we convert this T2, because we want to find T2, so we take T2 from this formula, we take T2 out to be the subject. So T2 equals 36 degrees Celsius plus 25 degrees Celsius. Okay, 25 is the initial temperature. Here is minus. We bring it over to the other side of the equal sign. It becomes plus. So minus here, we remove it here. It becomes plus. So 36 degrees Celsius plus 25 degrees Celsius equals 61 degrees Celsius. So the final temperature is 61 degrees Celsius. Okay, for the heating of the copper from 25 degrees Celsius. All right, friends. Thank you very much for watching. I hope you learned something good today. Okay, before we spoke about how to find the calorie, to find the heat capacity. Okay, we had 2 questions before, and today we look at how we find the initial temperature and how we find the final temperature. Okay, so I have shown you everything. Okay, thank you very much for watching, and I hope you learned something good from this explanation. Okay, I make the questions become very, very simple. The explanation becomes so simple. Okay, so simple, so simple. So you look at it, you understand it, okay? See, I cross them, I cross this unit, they are out. I make very simple, we write down what we know here, and then the formula is also, we convert them, we make it very, very simple. So you look at this, oh, it's just a piece of cake, okay? You know how to work out questions like this, okay? From the previous video, okay, this one as well. Okay, for those who haven't subscribed for me yet, please do. It's really a great encouragement for me to continue producing new videos. And don't forget to press the like button. Give your comments. I need your advice. I need your ideas, okay? And you may share the video as well. Thank you very much, and I will see you in the next video.